Hi everyone. We're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers. This is a geometric series. This is the nth term and this is your sum. So we're going to check for condition 1 because condition 1 and condition 2 have to hold before the statement is true. We check n equals 1. When I plug in 1 into the sum here, it should equal my first term. So I'm going to plug in 1. So I get 1/2 of 2, and that equals 1. So that checks. Now condition 2 states if it holds for some k, then show that it works for k plus 1. So basically, I'm going to write this out again with k. It's plus 3k to the little 1 equals 1/2 3 to the k minus the big 1. And I say little and big just to make sure you write this down right. Now I'm going to add my next term and check for the k plus 1 here. So we have 1 plus 3 squared plus dot 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 plus 3k to the minus k minus 1, little 1. The next term is going to be 3k, and we discussed that in the previous video, equals 1/2 3 to the k plus 1, because I'm adding the 1 to that, minus the big 1. Now, this equals this sum right here, so I'm going to copy it down. 1/2 to the 3 times 3 to the little k minus big 1 plus 3 to the little k. Now in this video, I'm going to slow it down here a little bit. I want the left side to look like this right side here, and I have the 1/2, but it's not inclusive with this guy standing outside of this, inside of this quantity here. So basically, let me show you the common denominator way, minus big 1. This 1/2 of that is like over 2 plus 3 to the little k. Now, when you do that, we need to have the same common denominator. So basically, if you cross, just cross up. So 1 times 3 to the little k minus 1 is just that, plus 2 times 3 to the little k. So that's what we're going to get. Alright? I'm going to go ahead and erase this because I want to move this up and show you a different way. Basically, in order for him to join here, I had to multiply him by 2, because 1/2 of 2 is just 1. So you can do it the way I just did it, or just know if you want him to come in and join this group, he has to be multiplied by 2. So you can think of it that way when you have the 1/2 here on the outside instead of as a common denominator. Now, from here, you're going to count how many 3k's you have. We have 1 3 to the k here, and we have 2 of them here. So that's a total of 3 of them. So we have 1/2 times 3 times 3 to the little k minus the big 1. Alright? There were 2 here and there were 1 here. Now from the previous video, you should also know that this equals 3 times little k plus 1. Just check it out and plug in some k's. And then we're going to subtract the big 1. Alright? And so this does equal what we want it to. And so we have proven which is what we wanted to have proven. And condition 1 and condition 2 hold. So the given statement is true for all natural numbers n. Thank you and have a nice day. Bye-bye.